This video will cover number 3 from the Chapter 3 test version 2. And in that problem you were given this table that hopefully you recognized from your 3.5 notes. And in that table we had to fill out information about number of sides and then the measure of an exterior angle and an interior angle of a regular polygon. So regular meaning the sides are all the same length and the angles interior and exterior are all the same size. So there were two guiding principles in 3.5. The textbook told us that the sum of exterior angles, no matter what, for convex polygons is going to be 360 degrees. And the textbook also told us that the sum of interior angles for convex polygons was always going to be n minus 2 times 180. Now, where did that come from? Well, that came from splitting shapes into triangles. So, obviously, a triangle has 180 degrees. We've proven that before. But then we said, how many triangles are in a quadrilateral? And we made cuts across it, and two triangles in a quadrilateral, so that's 4 sides, minus 2 times 180, and that's where the 360 comes from. Pentagons, you can draw 3 triangles, so that's 5 sides minus 2, or 3 times 180, etc., etc. Now, this is not asking for the sum. This is asking for a singular exterior angle and a regular polygon. So how would I find that? Well, if the sum of exteriors is 360, and it should be split evenly in a regular polygon among the number of angles that you have, then what we're going to do is divide by the number of sides, which we'll call n. Okay? So 360 over n is what guided you in this row. Same thing here, the sum of the interior angles, if you divide that by the number of sides, or angles, that's what should be guiding your work here. N minus 2 times 180, if I can squeeze that in, divided by n. Okay. Now, first up, I've got a 5-sided figure of pentagon. So 360 divided by 5. What would that give me? Well, 72. So we fill in 72 degrees for the measure of our exterior angle. Now there was one other piece of information that would be really helpful to know. At this point, with this formula, you can go ahead and figure this out, but it would be really handy if you knew that an interior angle and its exterior angle make a straight angle. We know straight angles are a total of 180. So if I've already got the 72, the easiest route to get from here is to take 180, subtract 72 from it, which gives us 108. And sure enough, if you follow this formula, which would be 5 minus 2 times 180 divided by 5, 3 times 180 divided by 5, or 540 divided by 5, you would get 108. But that supplementary relationship here really makes filling this chart out a lot faster. For instance, here I know the exterior angle is 8. So all I have to do to get this is, I kind of did it already. I meant to write 180 minus 8, which would leave me with 172 degrees. And then here, 150 for an interior, 180 minus 150 gives me 30 degrees. And so I've got most of the chart figured out. Now, figuring out how many sides is a little more complex. We're going to have to rearrange our formula a little bit. So what I know in the second column here is that an exterior angle is 8, interior angle is 172. I'm going to go ahead and work with the exterior angle because the formula is so much simpler. So I know in the second column that if I took 360 degrees, divided it by the number of sides, I would get 8 degrees. So I'll just solve for n by multiplying n on both sides and dividing out the 8. It turns out that 360 divided by 8 is 45. That's 45 sides. Let's do it again for our third column where we have a 30-degree exterior angle. So let's see, 360 divided by n equals 30. If you follow this pattern here, you should know that all I'm really going to do is switch the place of the 30 and the n. So 360 divided by 30 equals n. 30 goes into 360 12 times. So a 12-sided regular polygon. And that concludes this video.